Are we up and ready? Let's have a quick look. Yeah, okay, that looks okay. Development environments for programming. What do we have? Well, a confusing mess is the answer. This is Windows 11. It's a basic setup, which I haven't messed around with too much, obviously. And okay, and it does strange things like that. This is well, they call it an operating system, but it isn't. The operating system underlies Windows 11. Windows 11 itself is a server system, really, at the end of the day. That's basically what it does. It's a service provider. So, there is a distinction, because the operating system goes back into the 90s. The operating system hasn't changed much at all over the years. But Windows has. Windows has changed a lot. Not necessarily for the better. And not all of it works. So, when developing, what do you want to think about? You want to think about your environment. You want to think about how you are going to develop. And if we go to whatever this is, the web, and we type in something like integrated development environment, programming. Let's put in programming, shall we? Programming IDE for Windows. Yeah, okay. So here we go. This is what starts coming up. Integrated development environments. You get things like JetBrains, Microsoft Visual Studio, Code Blocks, CodeLite. God. And the list just gets longer and longer and longer the more you look. 12 best IDs for programming. Yeah. All of these IDEs, integrated development environments, provide you with basically a text editor and a way of controlling your workflow. Some are good, some are bad, some are difficult to use, some are confusing and complicated. I'm going to go for something simple. Probably won't even come up on here. No, they all seem to be congregating around specific Windows-based ones. I'll go for something more generic, something that I know will work on Linux, Macs, and Windows. I'll go for Qt. So if you go into this garbage thing and you pressing Qt, it will come up as a cross-platform software development, design, development tools, that kind of thing. It's at qt.io, www.qt.io. I'm not sponsored by them. They have refused me permission to engineer stuff, certain stuff online. I am restricted in what I can do online and on stream, should I say. But if I use it sensibly and I don't mess around too much, we should be okay. We should be okay. Now, I did mention that all of these IDEs are basically a text editor. There you go. It's basically a text editor with text in it. That's all they really offer. Somewhere for you to type with pretty colouring to mark special things. Very nice. Very nice indeed. Highlighting. Most languages that you can use in these come under modules. Qt comes with C++ and Python. Something else. Which I'm not bothered about. I don't care about what they offer. What all IDEs come with, or should come with, if you get a half decent one, is a C compiler. Because most languages are based on the language C. Again, derived from the 1980s. So you'll usually find that somewhere at the heart of these IDEs. Where it's hidden doesn't matter. You can use it from anywhere, usually. And they're not too difficult to work with. And C is a special language in which there's only 15 commands. Yeah, 15 real commands in the C language. And everything else is derived from that. The idea of C is to keep it as close as possible to how the CPU works. It's the fastest, apart from assembly language and, of course, machine code. So it is the fastest language in those terms. People don't like programming in C because you have to build it up. You don't get things automatic. For instance, opening a window, you don't get automatic. Because operating systems don't do that kind of thing. Windows does that kind of thing. And that's where all the problems are caused, when you start having to interact with things like windowing systems and stuff. But it's up to you how you want your application to look or what you want it to do. Now, if I use anything out of Qt, then it's copyrighted by Qt, obviously. But you don't need to. It's the same with Microsoft. If you use any of their libraries, then it's copyrighted by them. You need a license if you want to sell it. But you don't need to. You can use anything you like. So, be aware, be careful. If you are thinking about doing a project which could be sold later on, be a little bit careful about what you do. What we got here? Vulkan, Midnight, testing multiplications in the AI experimental. Where am I with you? So is that what's open? Yes, it is. Okay. So this is in C++ by the looks of this. Just run it. See what it's doing. It shouldn't do anything. AI window update. So that's an updater. Okay, so that's working. Lovely. There's nothing on the window, is there? Okay. So that just runs a window. Alright. Don't really care for that. Create a project. What shall we create? So all of these are Qt ones. Oh, it's Python they have here. Do we want a window? Plain C application. I suppose we can start there. We'll choose that. Untitled. Let's call it Logic, because that's what I will be looking at. Go up one. New folder. What should we call that? I'll just call it dev. That'll do. User's default project location. You see, can't be as much simpler than this. Next. Build system. May as well use QMake. It's here, so can use it. Can use CMake if you want, or QBS. I'll stick with QMake. It's a nice, easy one to work with. Yeah, desktop. I'm using MinGW. 64-bit. Using MinGW because I don't trust MSVC as much. This one's simpler and doesn't make as many cock-ups. We can have a quick look at its details. It will give us a debug that looks like that, a release folder, and a profile folder that looks like that. Lovely. Okay, that'll do me. Don't need to change anything. Add as a subject. We don't have any version control on Windows because it doesn't come installed or as standard. We could add it to Git. Oh, I do have it in, do I? No, we're not doing that. So, none, finish. And it'll open, and there you go. If you run this, it'll say, down here, under Logic, Hello World. And that's it, basically. You've now got a program. This is not using any Qt whatsoever, it's just using pure C, and there's nothing really here. We can get rid of that. Right, so that's all we've got. We've got one file called main.c. This is where things can get interesting, because C doesn't have much. It's got these header files, which we can look into. So this is the header file, and this gives us a lot of bits and pieces that we can use within our program and it looks very, very complicated. And if you're not used to programming, it just looks like garbage. But what it does allow us to do is use the functions that are inside of stdio.h. So the best way forward is don't look at the file. Go to stdio.h. So here's the documentation for IBMs. Gives us clear, seek, write, print. So it's got read and write in here for files. F stands for file. So file write, file seek means seeking a position within a file. S printf. Yeah, S stands for something on getC. Define types, so we can define things ourselves or have them defined within other files and use them as headers. It is a header file that I'm looking to make eventually. So there's pretty much garbage there. So we've got a randomizer, ASCII to integer, So there's bits and pieces on that one. It's an interesting file. So null is in here, that's useful. End of file. Maximum number of open files. Maximum length of file name type of thing. It tells you what they all are. Standard error, standard in and standard out. Library functions, okay. Yeah, looks okay. File streaming, so sends formatted output to a string. Oh, that's what it does. That's nice. So you can read all about the different commands that they have already constructed within the C language. And these give you functions, basically, which you can use yourself. It's basically so you don't have to keep reinventing the wheel. That's the basics of it. So you can use that as reference if need be. So logic. What do we mean by logic? So if I put a star and a slash in, and then a slash and a star, okay. I've got it the wrong way around, haven't I? Yeah, that's better. There we go. This gives you like a notepad where you can just type. So let's give it a title. Logic. Currently, Boolean logic is used by all CPU designs. Okay. So Boolean logic is a standard industry logic system for all computer designs, or CPUs, and is based on binary. So we'll put that in. Ones and zeros. All computers use ones and zeros, basically. And they make their decisions using ones and zeros. So, what I would like to do is not use ones and zeros. So, let's put our idea. Can we change from the base binary logic system to something else? Well, without remaking a CPU, no, I guess not. But we can program. So we can take our binary logic and twist it possibly into something like a double helix and mess around with it and see what we can produce as a different logical system for a computer to use. What would be the value in doing that? So, what is the goal of this? It's basically to create an alternative way to control AI systems. Now that sounds pretty far-fetched, doesn't it? But is it? Is that too far-fetched? I mean, that would be a premise which you could sit down and think about for years, and I have done. So, how could we go about this? Well, we could use a method. Use a base 3 number system to replace binary. Which is base 2. Oops. But how can you do that? Computers will only accept 2 alternatives. But if you use base 3, you've got 3 alternatives. That's a bit awkward, isn't it? How would the computer recognize the 3rd alternative? Trick. It doesn't have to. The computer doesn't need to know. The computer can quite happily carry on in its binary world, and what we can do is construct a program in base 3. That sounds silly, So why has it never been done? Basically, probably nobody's ever thought of it. Or thought to do it. So what I'm proposing is to make a function we can use C, it doesn't matter what language you use, some kind of function. So in C it would have to have a return value, and that's going to be an integer. It's going to be a 0, a 1 or a 2. Okay. So we can have an integer. It'll need a name. We'll call it base 3. And for base 3 we'll need some brackets for its inputs. And there we go. It does nothing, so we can just return 0, because it doesn't do anything. Okay? And that's how you program. That is now a function which we can call. So we could, for instance, make an integer called test1. We'll put that equal to 1. Okay. We can now we'll make sure that the program knows about it. Int base 3. We'll just make sure it knows about it. There we go. All I'm doing there is I'm telling the compiler to expect this function to exist somewhere within the code. So that's all I'm doing there. You can put this first. You can put this code up here. Most people leave main as the last function. It's up to yourselves how you want to do it. It doesn't really matter. So, if we put test1 equals the return value of base 3, like that, that's calling the function and returns the value, which is 0. We can then ask printf, which means it's print to the console, which is here, this logic thing at the bottom. Print to this console whatever you type in. So I can type in something like yeah, okay. Test1 equals, and then we have to put a code in for a variable, and I'm trying to find %, which doesn't seem to be on my keyboard. Has somebody stolen my % sign? Maybe it's that one. Yeah, that looks like it. And it's a number, an integer, so %n. I think that's right. And the \n means new line, or carriage return, depending on what you want to call it. And we'll have to put in comma and test1. and all commands end in a semicolon. That should be valid. I'm doing this from memory, so I don't know if %n is valid or not. Okay. So run that. Maybe not. Save it first, that might help. File. Save all. And does that just run? This run configuration? No, I don't want to do that. I want to do this one, don't I? Yeah. Run. And it's crashed. That's not right. That's wrong. So it's % flags. %D. Oh my god. Is it just Control S? Yeah. There you go. Hello world. Test1 equals 0. We set it to 1. So what happened? When we put test1 equals base 3, it's returned 0. If I put 2 there, and I press save and run, there you go, test1 equals 2. So it's taking on this return value. And that's important. We can now program base 3 to return a value. So we'll take in a result. No, we'll have an int. Int result equals 0, or negative, as we're going to call that. Thought. And we can now return result. Like that. And that will do exactly the same thing. It'll put test1 equal to 0. We can run that. And there you go, test1 equals 0 because result equals 0. Right. Now we're getting somewhere. We now have a variable which we can change to either a 0, a 1, a 2, or a 3. 0, a 1, or a 2. Sorry, we can't use 3. Not in base 3, we can't anyway. It's like in base 10, which is decimal, we can't use 10. 10 is comprises of two numbers, 1 and 0. So 3 would actually be 1 and 0. Interesting, but true. So we can do anything we want in the middle. And we can take in values. Now, because it's base 3, we can take in 3 values. Do we want to? Okay, let's... no, I'm not going to do that yet. That will be going a step too far. We want to play around with the result of base 3 in a logical way which would replace Boolean logic. So it's some kind of comparison. So here, structure. And that's your program. Not very intuitive, I know, but there you go. You've now made your first program. It's working. It's giving out the correct results. We've tested it along the way to make sure it does. This gives out the correct results for what we've programmed. We know what to expect. But once we put this in, or once we design this, we have to design this in a way that we know what to expect. But that's the whole point of it. Do we want a system that we know what to expect the result of? Currently, we can have true and false. We need true, false, and maybe. Yeah. I think you can see where this is going now. So what we want here is to pass in a value. A Boolean logical value. To convert to base 3. But there's only 2 values, and we need 3. That's where it becomes interesting. Can I improve your vision on this? 140. Does that look any better? Let's just let the stream catch up with me, my god. Can we do anything with this one? Oh, we can. Alright. That's a bit better. Just make the text a bit bigger for you. So, what can we do? Well, we can ask it for an int value. There we go. Declared here, yes, that's correct. Oh, right. That's going to be confusing. Let's get rid of that one. I don't normally work this way around. There we go. That's better. Okay. So it's now saying that we've got an unused parameter value, which is fine. My problem here is a hash define. We've got an if def, yeah, okay. Okay, it's false, isn't it? 0. Doing this way around, aren't I? I don't like this. I never like this. It's true. And hash define. Maybe as 2. If a value is equal to false, then result equals false. And if you can see where this isn't going, it's not going to work, obviously. Value is equal to true. Result is equal to true. I'm going to put result equal to 99. I'm going to use 99 as the error. What is wrong with you? Yes, I know source has changed. Thank you. Okay. So now, if we put in false here, we should get a return value of false, which is 0. That's the idea. That should be a valid program now. I think it is a valid program. Put space in there, just to make it look better. We'll try running that. There we go. Test 1 equals 0. Well, we set it to 99, and it now equals false. 0. Okay. True. If we run that, test 1 equals 1, which is true. But where's the maybe? Where's the third value? Well, this is where things get interesting, because we can use something called a scope. Scope is these brackets here. As you see, 2 brackets. There's one at the start and one to close. It's called a scope. As you can see, there's a scope here. Anything outside of these brackets is in global. Anything within these brackets is within the scope of base 3. Anything within these 2 brackets is within the scope of this if statement. Yeah. So that gives you an idea of why we're using these brackets. Alright, which means we can now put multiple commands for the if. Yeah, we've got to alter it to do that. So what is the chance of a false turning to a maybe? And what is the chance of a true turning to a maybe? Is it 50-50? No, it's not. And that's the catch. There's your catch. What is the chance of it being maybe? Don't be afraid to note as you go, because you'll finish something, you know, the door will go, the telephone will go, and you'll come back to it and you look at it and you think, what the hell was I doing? I've been there many a time. That brings in probabilities. And this is where the major problem lies. You can't have probabilities on a computer. Computers cannot deal with probabilities. Which is why we have Boolean logic and binary. But you think, well, modern day computers can do random numbers and stuff. No, actually, they can't. And we'll just say that as a fact, not as a maybe, not as a discussion or anything like that. Modern computers cannot generate random numbers at all. They can pretend to, but they can't actually generate a random number. And that's where this becomes a problem and not a solution. This is where you have to come up with something to solve what computers today cannot do. You can't make a random number generator because that's impossible. Otherwise, it would have already been done. Well, it has been done, but it was a specialised piece of hardware that is used by the British government to actually create random numbers. And it's a very interesting piece of hardware. Details of which I will not be going into. How do you have a chance? What we're really asking to do is divert the result into something else. So let's assume that all situations that will ever be encountered have an equal chance of being true, false, and maybe. So there's a 33% chance of each one. So the chance that one of these changes to maybe is half of that. Well, actually, no. It's 33% of that. So those two become the full one. That becomes the third. That becomes the 33% chance. We divide it by 2, you've got 16.5. Well, that doesn't work either. Because that's a simple assumption and it's not correct. So if everything is true or false, they are 50-50. You then have to reduce them to 33%, and then it's 16.5% of that. So you have to multiply by 0.016. Yeah. I'm going to have to sit down and do the math on that. There's a little complicated piece of maths there. Because your starting condition isn't your ending condition. You're starting with 2 and coming out with 3. So to start off with, you only have these 2 at 50-50%. This doesn't exist. We then have to change those 2 to 33% each. From 50%. Right, that makes sense there. Yeah, it's 16.5, isn't it? It's 0.1. Yeah, it's 0.016. Have I trapped myself? We can ask the computer. Using a %f. So instead of doing hello world, we'll do %f. See if that works out. 8.25. Bet you weren't expecting that as a number. So there's an 8.25% chance of a maybe. Which is wrong. Because that will go up to 16.5. So, right, got you. Ah. I see. You got to take it as a whole. So we have to take these 2 into consideration as a whole, not as an individual. If we take it into consideration as an individual, then it is 333333333, which is an impossible number, or 33%. So if we treat these as an individual, we've got to use them as 33. If we treat these as the whole result, then it's the whole result is 0.33. if we treat these as individual, these 0.165. Is that number correct? Is that what we want? Is that what we should have as a maybe? If something is true, can we devolve that into a maybe 8.25% of the time? Would that make logical sense? So there is a trap. That has to be 100. Because it doesn't make logical sense. There you go, 16.5, yeah. That makes logical sense because that's only half the result. So there's two results at 50%. 100 times that by two results. That would make 16.5 of all falses become maybe and 16.5 of all truths to become maybe. Alright, okay. That adds up to 33. It's 16.55555. No, it isn't. 16.515151515, isn't it? So we have a precision error. Is that acceptable? Yeah, of course it is at the moment. So we've found the trap. We have to assume everything has been taken into consideration to get a true or false. Okay. So that equals 100% at this point, doesn't it? So that is correct. I don't like this. But it does work. Is that logic correct? And I'm putting 3 question marks on because I don't think it is. And there's your problem. Firstly, we've got the problem of what is the percentage chance of a maybe instead of a true or for true or false to be replaced by maybe. The second problem is how do we create a chance to become maybe from whatever we decide is correct here without using a probability. I'll give you a second to think about that whilst I have a bio. The answer is, it's impossible to do. Otherwise, it would have been done by now. So how do you program it? You would need a set of numbers. You need a set of 1,000 numbers. Well, 999. And 0 is 1,000 numbers. Okay. Remember, there's no randomness. We need a set of 1,000 numbers, 0 to 999. This data can be stepped through to determine if things are a maybe. Okay. So how can we generate that? And how do we generate the stepped? Well, you would need to step through them 330. Yes, 333 at a time. So undo Control Z. That will give you 33.333% of results. supposedly. We'll soon see. Well, we will see eventually. So there's no randomizer involved. We're just going to step through. That's okay. We can do that. I don't mind that. We can't do that in base 3 though. We have to do that within the main program. So we need a step factor and data. Okay. We'll have to put that in there. That should be okay. So dirty programming would state user global. I haven't done chat, have I? I'm trying to keep this as simple as possible so people can follow the idea behind it. Not necessarily explaining why certain things can't be done, but I'm trying to do this in the correct, basic way to show you the thought process behind it. So we would need a set of integers from 0 to 999. So int data 1000. We may as well put the step in here as well. Int, actually. We could probably do that here. Hash define it. Oops. We'll just define that as 333 at the moment. I think that's going to be the best way. Now our data has to be populated. We can do that here. So for int x for God knows. While x is less than 1000, just keep adding to x. Okay. And all we're going to do is we're going to take our data, data set. We'll call it data set. Data set, and we're going to use x, and we're just going to make it equal to x. Complete waste of time and completely unconventional. We could use a step value but that could be dodgy. Because we've got data step, haven't we? And our step value, so we'll need an int stepper equals 0. Okay. That's the setup. This means this here needs to be altered to stepper as well. Here. It says there's too many arguments, of course there is. So, int comparator, that can go in there. And we can add if comparator is less than 333. I'm going to keep the scope because this all gets changed later on. Then result equals maybe. But now you know how I've come up with these numbers. So that really should be data step, shouldn't it? Data step, there we go. Yeah, that'll do it. We lose 1%, we lose 0.1% on that. Or we change that to 134. Sorry, 334. Which choice do we make? 333 is an odd number. We don't want it even, we need it odd for it to work. Okay. Right, so that's now reading correctly. So we're using the correct values now. It's at this point that things can get confusing. So we've got stepper equals 0. That should be less than the comparator. We should get a result of 2 instead of 1. Do we agree? Where did I put me 99? Okay, result equals 99. Yep. Test 1 equals 99. Make sure these all equal 99. That'll tell us if there's something going wrong, and 99 will show up. Actually, make that one 98. So I know the difference between main and base 3. So if we come up with a 99, base 3 hasn't worked. If we come up with a 98, main hasn't worked. It's simple. Well, should do it the other way around. Should always have 99 on main. Okay. Check. Check. So the answer to this set of instructions is maybe, or 2. Go. Test 1 equals 2. So it works. So if we then step we would then put the step instruction in, which is stepper equal plus equals what have we called it? Data step. Yeah. A semicolon. And we can run the same test again. So what we'll do is we'll rerun our function base 3 through the same sequence but after a data step, and it should come out with a different result. It should come out with true, which would be 1. So our expected results are 2 and 1. There we go. Test 1 equals 2, test 2 equals 1. That's working. Now, how do you get the randomness? Well, you can't. Not really. That's an impossibility. So we're not going to try and get randomness. What we can do is introduce this stepper instruction someplace in our program. Someplace within the main loop where it's not expected. So buried away in some secret dark corner of our main loop, we would have this stepper quite happily going along. Oops, done it again. Control Z. I wish it wouldn't do that. So the full instruction is if stepper is greater than 999, it becomes stepper minus equals 1000. So we just remove 1000 off it. That'll still work the same as it did before. So you test run it, and as predicted, 2 and 1 come up. It works the same. This goes in your main program loop. Okay. And this base 3 can now be called from anywhere within your program at any time, not necessarily within the main program loop, but from other places within your program at any random time. And we don't know how many steppers have been gone through. We haven't any ideas. We do need to check through on 3 and 4, don't we? So what we can do, we can test this out using a for next loop. It's just going to give standard data in a linear fashion though. That will result, if we do a for next loop on this, it'll just result in a linear fashion. So that's no good. Due to the function calls being outside the main loop. So that's your rules for this to work. So that's how you get your randomness without actually using random, which doesn't actually give a random number. But this doesn't actually give a random number either. It does exactly the same as the random number generator does, to quite honestly, but in a very simplified fashion. That could work. So what we've done is we've now converted true and false to true, false, and maybe. In a very simplistic way, which can't work by itself. It has to be integrated into something to make it work. But it should. And what we've got in as a result is a very, very simple function here, and a very, very simple way of introducing that function within into a larger program. And that's your basic method. So I think that'll work. The thing is, how do you find out? Well, you have to write a program, don't you, to use it. Simple. And we can do that at some time. Cool. I'm happy with that result. Pretty simple programming techniques, nothing advanced. Again, language you use to program in is up to you. This can be done in any language. It's obvious. It's just the basic maths of it to work it all out. But it is still wrong. We didn't use data set. Okay. Okay, that bit's alright. It's It's this bit, isn't it? Yeah, we're using the comparator. Here we go. Yeah, the correct version of this line is dataset. You're probably wondering why I've gone to the trouble of putting a dataset in. Because you don't need it, obviously. It's not a necessity. Awkward. Just check it works. I don't know if that should set it up in the right order. Please set it up in the right order. Yes, it does. Good. So it's the same. Okay. Lovely. So we haven't changed anything by adding that in, because that is just actually comparator and dataset should be the same number, and that's your safety check, your error check. If the comparator and the dataset disagree at any point in time, then there is a problem. But none of this is asking the underlying operating system for any information. I'm saying that because of how this other stuff works. So we could have used RND. Standard in, standard out types, file paths. No, it's not in this version, is it? They moved it, didn't they? Yeah. I don't even know what it's called these days. I just look it up when I need it. Could be in math. No, it's just cosine and garbage, isn't it? Roundings. Okay. That's all it is. Two upper, two lower. Yeah. Asserts. Limits local. Jumps, signals, args. Bool. What have we got in bool anyway? Just out of interest. Specifies whether bool true and false are defined. I get you, but that's in lowercase, isn't it? Not in uppercase. Fine. Trying to remember where random is, and I try not to use it, so I don't know off by heart which one it's in. So pseudo random sequence generation, RAND. This is what we're avoiding using. It's in the standard library. So std lib.h. What we can do is hash include std lib.h. It's just tab, is it? Yeah, tab will do it. And we can follow that symbol, and of course this gives us all the stuff for it. And as you can see, there's a lot of things going on in here. So they're using success as 0, failure as 1, so false is 1. So we change these around, do we? Okay, so we'll go by standards and we'll change those two around. Okay, I hadn't checked them, I just typed in numbers that I decided on at any one time. Go back to this one. So true is 0, false is 1. But you can see how they've renamed it so it doesn't mismatch with people using true and false within their own programs. They've renamed it. So there's a duplication of efforts going on already. Causes me a lot of problems. So what are they called? Rand. Just stick it here. RAND. So they're giving it a maximum value in hexadecimal of 7FFF. 2, 3, 4. So what's that? Hexadecimal, is that 64,000? Probably. So they've got an export into your program, a random void, okay. Seed, yeah, the seed random. So they're exporting that. They've got the hash defines for the various ways you can use it. Okay, so that's, yeah, alright. So that's so it can use itself into itself. Then we've got the Microsoft vCRT. Yeah, good for you. Good old Microsoft. And that's all they're going to give us in here. Okay. That's fine. So it's an extern. Great. Means we don't get to see what it does, basically. Typical. Absolutely typical. would like to have delved more into the code, but I don't think they're going to give us much more in here, are they? Let's have a look. Yeah, they're using modulus. Alrighty. And then there's an example. Compatibility. Right, the function accesses and modifies internal state objects which may cause data races and concurrent calls to rand or srand. So we have a problem here. If you are using this within a game and you are using the randomizer itself, the one thing you don't want to see happen is your logic system blocking anything to do with user input and random numbers being generated for like hitting targets or whatever within the game. You want to stay away from something like RND or RAND as much as possible. C++ library implementations are allowed to guarantee no data races for calling to this function. So you may want to go to C++ if you want to avoid the data race. That's basically tying up your CPU whilst trying to use one area of the system. So, yeah. There are massive complications to using a random number generator. Massive complications. And this is where a lot of so-called bugs come from. Especially in games, where things are coming back as the wrong value because of either the data races or overflowing of variables within the maximum value. Oh, it's 32, not 64, sorry, my bad. So that's what that meant. Now that's the highest number it can generate on the standard library implementation, which doesn't really matter. It's enough usually. You can use this instead of doing what I've done, but I think this implementation avoids a lot of the problems that using, especially within a game, RAND, because RAND can mess things up royally. And when you've got such a simple way of doing it, why not just do it the simple way? There's no function call here. You can move the globals into the main loop, because that's why I put them as global, because I don't know what your main loop's going to look like. So that define can go into wherever. But this data set, think about it. Where do you want to pull your data set from? I've just placed in 0 to 999 into the data set. Yeah, you don't have to do that. You can take your data set from anywhere, as long as there's no duplications of numbers within that data set and they go from 0 to 999. That data set can be anything you want. The best way of doing it is to write your own data set. I've just been lazy and done it automatically. Because that will then give you a standard data set for controlling your system. You can also control the probability. So this controls the probability. And this controls the effective result. Basically, you don't actually need the data set. That is not a requirement. You can do it on the data step itself. The data set is not a requirement. Ugh. Nearly got it right. So basically that's optional and could be missed out. Depending on memory needs and control flow. It also gets rid of a global. Or possible global. If you can't find a place to put it, just remove it. Simples. But that's the full version of how to turn base 2 logic into base 3 logic. Not very complicated. You can add a bit more random. Well, should you? No, we'll keep this as the simple way of doing it. Yeah. A simple method to convert base 2 logic to base 3 logic. Why hasn't this been standardized or done in the mainstream? Really, it's due to the fact that people don't want computers to guess. They want computers to be correct. They don't want this undefined behavior. So really, NB, using base 3 logic invites undefined behavior from any logic system designed or design. that's the effect. But that's the effect that I'm after. It is that undefined behaviour. How the hell do you spell behaviour? V-I-O-U-R. Okay. I knew there was something missing. Still doesn't look right. Oh no, you can do it without the U. Okay, we'll do it without the U. I don't know. Language. There's too many of them. So I think that wraps up the basics. I'll keep that there. Yeah. I think I'm happy with that. All right. So what I would like to do is include this information within a header file for some artificial intelligence. The logic tree, funnily enough, is exactly the same as base 2. It's just got the extra split. So your actual programming for your AI doesn't have to be too much different. You've just got to remember that there is a possible result of, I don't know, something. Maybe. Shrug. And that, to me, then becomes interesting. A computer stops being a computer at that point in time. 1 plus 1 doesn't equal 2. Maybe it equals 2. Can you see where this is going? There's no certainty. I like that idea. So that's come up. Yeah, oh, good. I think we're done. So that's how I set up the programming environment, how it runs, very simply. Just doing test programs. Haven't used any complex programming languages or anything like that. I can experiment quite happily using this system and play around with things. And it's nice. It's nice. It's better than using something like Visual Studio, which is a lot more complex and requires a little tad more setup than Qt. So yeah, try it out. Some people like it, some people don't. I don't know. I do have VS Code. I think out of all of them, VS Code is probably my favourite, but it can be a little awkward to use, especially in Windows. It's weird. In Windows, it's harder to use than it is on Linux. Yeah, go figure. Weird. Right, I'll leave it there. Thank you very much for joining us on the stream. If you've popped in to have a look to see what's going on, that was a basic environment, a basic program on base 3 logic, and If that sparks any kind of imaginative response, or you would like to take it further, let me know. You never know. You could have an idea of its implementation that I haven't thought of. You probably will. So take care, and above all,